at least dissertation council members. Then we can begin. Okay, dear council members, dear colleagues, I think that we can begin. So according to the order of number 1.10275 NK of SD University dated July 4th of 2025, the permanent composition of the dissertation council for the defense of dissertations for the degree of Doctor of Philosophy PhD in the field of AD06102 computer science and the specialty 6D07040 computer engineering and software at SD University has been approved in the members of 4 members. So it's me, Bogdanchik Andrei Vladimirovich. I'm a chairman. The professor, foreign professor Vitaly Levashenko from the Jelina University, Slovak Republic.
It's me.
Yeah, thanks. The Al-Haditi Mohammed Al-Fathil, also PhD in specialty computer science and information technology, assistant professor at the University, the member of dissertation council, and Dana Utibaeva, scientific secretary of dissertation council, also assistant professor at the University. At the meeting of the dissertation council for the defense of dissertations for the degree of Doctor of Philosophy PhD in the field of 6D06102 computer science and 6D07040 computer engineering and software regarding the review and acceptance of Zhanserik Nurlan's PhD defense, the permanent members of the council, in accordance with the requirements of the regulation of dissertation council of SD University, appointed 4 temporary members of the dissertation council. The temporary members for the dissertation council for the dissertation topic of Zhanserik Nurlan are Raisa Skimbaeva, Doctor of Technical Science, Professor of Satpaif University, Kasambek Ozhekenov, Candidate of Technical Science, Professor of Institute in Automation and Information Technology at Satpaif University, Shamai Pakizar, PhD, Professor of School of Information Technologies and Engineering in Kazakh British Technical University, and Dana Turlukozhaeva, PhD in Specialty 6D06102, Radio Engineering, Electronics and Telecommunications, Senior Lecturer of the Department of Electronics and Astrophysics of Al-Farabi Kazakh National University, Almaty. So these are members of current dissertation. Okay. Additionally, based on the recommendation of the Committee for Quality Assurance in the Field of Science and Higher Education of the Republic of Kazakhstan, the following 2 individuals were appointed as additional experts for the redefense of current PhD applicant. The specialists invited to this dissertation council are Katipa Chezhimbayeva, candidate of technical science, professor of the Department of Telecommunication Engineering at Energy University, named of Gumarbek Daukimbayev, Almaty, Kazakhstan, and Alisher Skabylov, PhD in the specialty of 6D06102, Radio Engineering, Electronics and Telecommunications, Senior Lecturer of the Department of Electronics and Astrophysics of Al-Farabi Kazakh National University, Almaty, Kazakhstan. Okay. So currently at the meeting, we have 7 members of the council. So 1 is absent. Raisa Kabina said that she's ill. And the quorum for the holding of the council members is met. Out of the 8 members, we have 7 participating in this meeting, which is more than 2 and 3 of the total composition among them. And considering the nature of the dissertation under the review, we have 4 specific members. And the meeting is deemed legitimate. It's proposed to begin the work of the dissertation council meeting. Are there any objections? No? Okay. There are no objections. We'll begin the work of the dissertation council meeting. So for this meeting, we have an agenda which includes the defense of the dissertation of Zhanserik Nurlan on the topic of development and research of routing algorithms for wireless mesh networks in the specialty 6D07040 computer systems and software. The dissertation was prepared at the Department of Computer and Software Engineering of the Gumilev Eurasian National University. The defense will be held in English. The defense is being conducted for the 2nd time. The dissertation is presented as a series of publications. The official reviewers, Sayat Akhtanov, the PhD Associate Professor in the scientific field 20200 Electrical Engineering, Electronics and Information Technologies, Associate Professor of the Department of Electronics and Astrophysics of Al-Farabi Kazakh National University, Almaty, Kazakhstan. And also Rasim Soliv, PhD and Associate Professor, Director of the School of Digital Technologies in Narhos University, Almaty, Kazakhstan. And also one change worth noting here is that one temporary member of the dissertation council and one official reviewer voluntarily withdrew due to the personal health reasons, and new members were appointed on their place. The scientific consultants of the PhD applicants are Tamara Zhukabayeva, PhD Associate Professor of the Department of Information Systems in Gumilev Eurasian National University, Astana, and Mohamed Atman, PhD Associate Professor of Computer Science and Information Technology in the University of Putra, Malaysia. Any questions regarding the agenda of current meeting? No? Okay, thanks. Then we approve the agenda. Anyone? Okay, yes, we approve it. Who is in favor? Okay. The agenda is approved by open vote. The speech is given to the academic secretary of the council meeting, Dana Otibayev, to review the personal documents of the candidate Zhanserik Nurlan and their compliance with established requirements. Please.
Thank you. Hello, dear professors. PhD candidate Zhanserik Nurlan for his PhD defense on the topic development and research of a routing algorithm for a wireless mesh network in the specialty 6070400 computer systems and software submitted the following documents: application from the PhD candidate, review from scientific and foreign advisors, positive conclusion from the department where applicant was graduated, recommending to the dissertation for the defense, the dissertation in a series of publications in electronic format, in a hardware copy, also a list of publications, then notarized copies of his higher education, a copy of transcript and the order approving dissertation topic and scientific advisors, and conclusion of the ethics committee where he was graduated. Also, personal information about the PhD candidate. All documents submitted by the candidate are complete and they comply with the requirements of Committee for Quality Assurance in Science and Higher Education. And we may proceed with the review.
Thank you. So are there any questions to the secretary, scientific secretary of the PhD candidate regarding the personal file materials? No questions? Okay. Thank you. The floor is given to the candidate for the presentation of the main points of the dissertation. Please proceed. So around 20 minutes is for you. Please share the screen and you can proceed.
I can start, yes? Okay, hello everybody. Can hear me all? First of all, thank you all for participating for this FIVA. My research work is on the dissertation topic is development and research of routing algorithm for wireless mesh network. As said before, mentioned my local supervisor is Professor Zhukovaya Tamara Kukenovna, and the foreign supervisor is Professor Mohamed Osman. What are the purpose of the dissertation work? The aim of the dissertation research is to develop a routing algorithm for wireless sensor mesh network in order to improve the viability, lifetime of the sensor network. The subject of the network, the subject of the research is the wireless sensor mesh networks. The objects of study, characteristics of nodes, controllers, including models in routing algorithm, energy efficient algorithms, routing protocols for wireless sensor networks, which can be described as wireless sensor mesh networks. The tasks for this dissertation work is analysis of existing methods of algorithms for routing wireless sensor mesh networks, development of models, and study of block diagram network topology, interconnection of nodes, nodes providing energy efficient routing of information and data from sensors, development of models and study of characteristics of heterogeneous wireless sensor networks, research and the comparative analysis of the effectiveness of routing protocols such as LEACH, SEP, ZSEP. In addition, EasySEP proposed EasySEP is measured using various estimation schemes, such as base station offset, field density variation, and variable nodes, energy for comparison with previous algorithms. The next one is algorithm development and software implementation of scanned data routing to the central microprocessor, which is the base station or the sink. Development of simulation system for wireless sensor network proposed on the simulator to test the effectiveness of algorithms and its software implementation. Scientific novelty. Proposed extended regional permanent election protocol has been studied so that two-layer heterogeneous routing protocol based and it's a hierarchical cluster. A modified method is provided for selecting the cluster leader as well as connecting nodes to the base station. It means that nodes transmit data to the base station in hybrid manner. Regular nodes are placed near to the base station, directly sending the data, and extend nodes are clusterized, which will send data from cluster to cluster and in the end to the base station, which is also the sink. This proposed method, increases the stability of the network before the death of the first node, which is the main parameter, and also increase the number of live nodes in the network. Later, all these parameters lead to the packet rate increase. It means larger number of environment events are monitored, sensor detected, and delivered to the base station. Simulation results, of course, show that improvement in the network performance is better in terms of parameters such as service life, number of packets sent to the base station, and the power consumption. In addition, results obtained with the proposed algorithm are compared with different protocols, as mentioned before, LEACH, SEP, and ZSEP. Proposed routing algorithm reduced the number of dead nodes by 2 times, increased the packet delivery rate, and reduced performance of overall network. Reduced average power consumption of the whole network is up to 34%, which is 1/3. Research content. Results of the study of the routing algorithm were for wireless sensor mesh network. Structural diagram, network topology, interconnection between nodes, nodes providing energy efficient routing of information and processing of data from sensors, algorithm and program for routing scanned data to the central microprocessor, and of course simulation graphic schemes of the efficiency of the algorithm and its software implementation. Relevance. Nowadays, their lifetime, the improved energy efficient wireless sensor networks directly depends and is simulated and is limited by the capacity of batteries inside, which cannot be charged. So it fits the nodes of the network, which is the main disadvantage of such network. To improve and extend the lifetime of this network, wireless sensor network scientists all around the world make continuous research work on this area and try to improve the routing algorithm. So various routing algorithms that minimize and optimize the power consumption of the sensor network nodes. Systematic review in this research shows that many, since the lifetime of the network is the main object for research, many authors, as we see here, do design challenges, which are low cost, large area, end-to-end delay, of course, energy efficiency, packet delivery ratio, routing itself, which leads to the throughput improvement, robustness of the area, robustness of the network, scalability of this network, link reliability, and so on. Design goal and systematic system model of the research work is mentioned as in table 1, which represents the nodes in a graphic mode, where vertices are assigned like N2, the node number with serial number 2, and 8 is the radio channel between, for example, node 5 and node 6. So that possible channels between these nodes are represented in the matrix. Then to find the optimal routing path between these nodes, this matrix is simplified according to their weight. And the optimal routing path is from the simplified matrix we see by the priority. If we look at the example, we see that, for instance, F1 routing passes through the nodes 10 to 9 by 22nd routing channel, and by 14th channel, and by 10th channel, and reach the node 5. And another example, the same for F1, F11 routing path occurs through 11 according to 27th channel, and to 7 according to 18th channel, and reach the node number 8. Proposed work is EasySEP, which is Extended Zonal Stable Election Protocol, and we explain the communication model in this graphic, where is the transmitter and the receiver, and the distance between them. K packets come in, receive or sense it, and the K packets delivered. And this is a radio communication model. Proposed threshold value. The proposed protocol is a hierarchical asset clustering heterogeneous routing protocol known as Extended ZSEP routing protocol with hierarchical clustering approach for wireless heterogeneous sensor network, in shortly EasySEP. This algorithm extends the version of ZSEP algorithm that prolongs the lifetime of the network. We improve the threshold value according to which the cluster head is selected. So this equation can be described by this Tn, where initial remaining residual energy is represented as equation energy of node after several rounds and its initial value, and K opt is the optimal cluster number, and expressed like this formula, where n is the node number, d is the distance between the nodes, m is the quantity of cluster heads associated, e is the energy transmitted, energy received, and the EDA is the energy for data aggregation, and E is the assigned initial power of this node, and m is denotes the diameter of the deployed network. We propose the proposed network architecture and flowchart. We divide the network field to three zones, where in the 0 zone or zone 1, normal nodes are located, which will transfer the data directly to the base station. And the advanced nodes are located in zone 2 and zone 3, which will form a cluster before sending the sensor data. So if we imagine the algorithm when the field or the network is deployed, first of all, it's checking if it's normal node or advanced node. Then if it's a normal node, then no need for clusterization, and then it connects the base station directly and tries to send the data direct to the sink. If the otherwise, if the node is advanced node, then cluster is formed, then the residual energy is checked. If this residual energy is the highest among them, this node becomes as a cluster head, and the other nodes become as a member of this cluster head. So it means that optimal cluster head is selected, and then data is aggregated from all the members of the node cluster, and this cluster head later sends this data to the base station. What are the simulation parameters? We deploy the network area for 100 and 100 meters square. We select 100 nodes. Energy initial value of them are 0.5 joules. Energy amplifier, energy free space model, energy for power amplifier, data aggregation energy, and receiving energy are considered like this. And we also have different parameters, like we extend the field area, and the sink is 150 meter on the x-axis and the 150 meter on the y-axis. And the round for simulation is 9,000, which is more than enough to see the result of the network. Clusters head associates, the quantity is 4. Then we come to simulation results and see that when we compare proposed ZSEP algorithm, which is the green line, we see that previous algorithms like Leach, SIP, or ZSEP performs gives the bad results according to the proposed ZSEP, and we see that they begin to die before the 2000s round, and the proposed ZSEP will in the graphic we may maybe see that ZSEP and SEP are in the same point, but we see that on the simulation results it's more than 1,000 rounds between them difference. And stability per ride, of course, is better than previous algorithms. And even in the end of the 9,000th round, this network continues living. Since the packet ratio is the highest among them, and average energy, residual energy on the nodes remain more according to other protocols, compared protocols. Then we also do different scenarios where we change the position of the base station and observe how the network work. And even we change the position of the base station, we still see the good performance of this proposed algorithm according to other protocols. The same packet ratio is the highest, and the average residual energy is still the best. Then we change the field density. We add more nodes to the field, and suppose that maybe more nodes can be located far from the base station, which will affect the energy of these nodes. And we still see that even we add more nodes to the field, network performs better. I mean, the proposed algorithm survives and reach the highest, shows the highest metrics on the graph. Same as for packet delivery ratio and same as for residual energy. And we see what we do and what we can observe if we add the initial value of the node to observe the energy value, energy added value to the node. And when we add initial value for 50%, the network lifetime increases twice. And it's also shown in the parameter in the graph, which is green line. Packet ratio is also the biggest, and of course, the average residual energy is the highest. Comparative analysis of these all networks of all protocols or routing algorithms are shown in this table. SEP, Leach, ZSEP, EasySEP network levels are different, as you see. SEP is heterogeneous, Leach is homogeneous, and other ZSEP and the proposed EasySEP is heterogeneous also. Network stability, when we perform the simulations, we see that it's medium. For ZSEP is high, EasySEP is the similar high, but then energy efficiency is the biggest in the proposed algorithm, and the scalability is also good. In conclusion, what we derive and what are the results? The extended regional ascending cluster head selection protocol was studied as a two-layer heterogeneous hierarchical cluster-based routing protocol. provided a modified method of selecting the cluster head, which is according to the residual remaining energy of the node, as well as the connection of nodes to the base station. Thus, it means that nodes transfer data to the base station in hybrid manner. Normal nodes they directly deliver the records to the base station, where extends nodes use clustering mechanism, and the cluster heads chosen among them deliver the data to base station, and taking into account energy consumption. This method increases the stability of the network, as we mentioned in the graphs, before the death of the first node, and increase the number of live nodes due to the previous networks, previous algorithms for around 48%. Packet transmission rate is improved by 16%, meaning that large amount of environments events can be censored, monitored, and delivered to base station. So these simulation results show an improvement in network performance in terms of parameters such as service life, packet sent to base station, and power consumption, which is average power consumption, to 34%. In addition, results obtained from proposed algorithms are compared with different protocols, as we mentioned in different scenarios. Proposal algorithms reduce dead nodes by 2 times, increase packet delivery, and improves the performance. Reduced the average consumption of the whole network, which is, as we mentioned, 34%, which is 1/3. According this research on this topic, dissertation topic, 7 works were published. 5 of them are in the Scopus database, 3 is in high-rated journals as Q1 and Q2, which is recommended by the Committee of Education and Science of Kazakhstan. Applied parts of the scientific works passed laboratory tests and implemented in Kazakhstan and abroad, in Malaysia, in the 5 in Kazakhstan. We see the practical implementation of this protocol in these companies, and during the conference got the bronze medal for best paper award. It's an international conference of students, graduate students, and young scientists in Tomsk. Obtained copyright holder of 2 intellectual property in the National Institute of Intellectual Property. These are the published papers in high-rated journals. Other publications, which we say this is a high IoT hardware-defined routing protocol for dynamic self-organizing wireless mesh networks, which is a conference. And in the one paper is published in local Kazakh language, Nurlan Zhanserik 2020 in international conference, scientific conference in Astana. Mesh network dynamic routing protocols, also in Scopus conference, which is held in Malaysia, and a comprehensive review of routing protocol in the wireless ad hoc networks, also the international conference, where, as I said, was awarded a 30-degree diploma. And the research internship was held in Putra, Malaysia. In Putra, Malaysia University in Malaysia. If we look at citation of my papers till this time, we can see that full citation of my papers is more than 200, and since the last Viva, most of them cited twice, which increased the citation report. These are my main high-rated papers, journals published in high-rated journals. This is the information about Scopus database and Web of Science database in GCR, Journal Citation Report. And we can just analyze what are the citation analysis. Most of them, if we talk about new technology, we can find that AI-based robotics in industrialized building manufacturing has been reviewed my paper. Computer vision and deep learning optimization reviewed my paper and cited. Digital twin system is also not old technology, which is also new in this area. Neural networks, deep neural networks also cite this paper. And according to this, like this, we see that each year, new technology of that year almost cited my papers. These are the acts of implemented, practical implementation of my work in these companies. This is a Malaysian company. This is Astana local company, Kazakhstan. These are the same Kazakhstan companies, which are totally 6. This is obtained copyright. This is, as mentioned before, the diploma of in my first conference, international conference in Tomsk, and it's a certificate. That's all. Thank you very much.
Okay, thank you. Thank you, Zhanserik Nurlan. So the presentation is concluded. So let's go to the questions, please. Any questions? No, please. We'll start with the dissertation council. Thank you. Yeah, any questions?
Okay, so thank you so much, Mr. Nurlan. I noticed like your work actually is impressive and you have many publications. So I can expect that from your supervisor, like Prof. Osman and Prof. Tamara, of course. So thank you so much. So I can expect, or you can expect there is too much questions.
Yes,
because yeah, as I see you have many papers, so I can expect a lot from you. Okay. Actually, I prepared some of the paper from your presentation and from your papers. So let me start maybe with the simulation. In the presentation, you mentioned that you made simulation, right?
Mm-hmm.
But actually, you didn't mention which type of simulation and like what is that? How you made that? Your work is by coding, or there is a platform especially for this?
Okay.
So because actually I'm really interested in this topic, I was focusing on it like last 6 months. So I just want to know like which simulation you have used.
Okay, thank you very much. The simulation was done in MATLAB, and code was written in MATLAB language. So we obtained the results. And these are the parameters for this network.
So why you choose like MATLAB? Because there is like special simulation, which is NS2 and NS3. It's special for packet and this routing.
Thank you. There is no need for special packet. I was familiar with this software, so it was for me best to use this software.
Okay. So actually also I want to know like why you specifically choose this dimension like 100 by 100. Like is there any reason to choose 100 by 100, and also why only specifically you choose only 100 nodes? Like why these directions and dimensions?
Okay, these parameters are taken from benchmark protocols to test my own proposed protocol on the same parameters, on the same configuration they do.
So based on the benchmarking?
Yes, yes.
Okay.
So I can analyze that proposed network or proposed algorithm show the best result according to them.
So how many, I mean, what is the type of routing models that you have?
It's in hybrid manner.
Hybrid?
Yes, yeah.
So what is the difference between hybrid and the normal one?
Normal one is mentioned like a homogeneous, where nodes have same initial value energy. In heterogeneous network, nodes are differ from each other. Some nodes may have less power than advanced nodes, which means that advanced nodes may have higher nodes, And to improve the network lifetime, we separate them from each other.
So this is
Integrate them.
the reason we can consider the advantage of like hybrid routing. You are using direct and clustering, right?
Yes, so advanced nodes do perform a clusterization, so that no need for each node to transfer the data to base station.
So you already compare cluster and
Yes,
hybrid.
Yes.
Okay. So should I ask more or is enough? Because I have plenty of questions. Okay. And in the improvement result, actually, you show the percentage. You said like 34%, but you didn't mention actually it's compared with which of the algorithm. As I saw, like you have SEP, EasySEP. EasySEP is yours, right? And ZSEP and Leech. So which one, like the 34 is?
Which one is taken?
No, yeah, for like counting the 34%.
Yeah, the main compared algorithm is ZSEP. So even from the graph, we can see that Leech and SEP are the worst, and the closest algorithm is ZSEP. And even when we take the same, as you said, mentioned, configuration parameters of this benchmarked network algorithm, performance are good. So this 34% improvement is done according to ZSEP.
ZSEP.
Yeah.
Okay, but if you could like take the average improvement overall, so once you mention, because you didn't mention based on my benchmark, it's your benchmark, right? The ZSEP is your benchmark algorithm.
ZSEP is my.
I mean, the ZSEP is the benchmarking, right?
Yes, but the parameters are same for all.
Yeah, I
All
understood.
all
Yeah, of
parameters
course.
take
Yeah.
the same parameter.
Yeah,
all
you
the
must take it all.
Yeah.
But the issue is like you need to mention in your like presentation that this is only compared with my benchmark, or you take average comparison, like the average for all of them.
Yes, average for
Yeah.
all the algorithms have the same parameters configured. So we see that the same parameters for my algorithm shows a difference.
Okay. So actually, I just like why you choose EasySIP, or what is the main difference between like your algorithm EasySIP and other routing protocol?
Why I compare them?
What is the difference between EasySIP and others?
In ZSEP, clusterization in the data set is done by, the cluster head is selected not according to the residual energy. It means that any node can be selected as a cluster head, which means that if the node has the low power, it may assign it as a cluster head. Since after several implementation, this node has low power, it might die immediately before sending the data. In my proposed EasySEP, cluster head is selected according to remaining residual energy.
Okay. So you consider the residual energy,
Yes.
and it has the threshold, right?
It is the threshold value proposed. Yes.
Okay. And you mentioned like actually about like the residual energy, and so what is the level of overhead that needs to track? You know, like when you have packet, you need to track them, and there is like overhead, especially if you are at the same node or you are sending to the base station. So there is like overhead
when estimating the residual energy.
No, the overhead between locally node
Okay.
and the destination or base station.
Actually, to find out if I understand your question well, to find out that the remaining residual energy of the node doesn't require overhead locally. But if we extend it to whole network, the overhead may occur.
So you mean if locally there is no
Locally,
overhead?
no overhead.
There is no consideration for overhead.
No overhead will occur.
Okay.
Yeah.
And if the base station, it could happen.
Yeah, if base station means that the overall network should send the residual energy value of each node, then overhead may occur.
So actually, like, were simulation conducted like for different base station position or just one in place? Have you have different scenarios maybe, or only in like just you have one base station, or did you have any different scenarios? Is it like fixed base station or?
Yes, it's fixed base station. We don't change the main result is obtained from the position where sink is in the middle of the network in this fixed static.
So it's static.
But when we do the scenarios, we try to change and see the network difference. How does the network perform in this scenario?
It's still performing well.
Yes. Here, the first graph shows that when we change the position of the base station, even it means that when we change the base station, some nodes may have far nodes which had a smallest distance. The distance may increase. Even in this position, network performs well.
So do you have any background about MANET, mobile ad hoc network?
Mobile MANET, mobile ad hoc networks.
You hear about it, right?
Yes, they are mobile.
Yeah. So is your protocol can be applicable for mobile sensor network or MANET?
It's mentioned as static. All the nodes are stable, fixed, and then don't move.
So it could be like for future research to be considered as.
Yes, as a future research, of course, can be observed, since like maybe drones will exist like a node sensing the environment. So it will be like MANET moving around and sensing the environment. But my proposed network algorithm doesn't mention that the nodes are mobile. It's fixed.
So I think I will have some question, but maybe later.
Okay, thanks.
Thank you very much.
Yeah, others? Dana? No?
Thank you. I would like to know some information here. How many energy consumes one node in your network?
Thank you for your question. Initially, it's when we simulate, the initial value is 0.5 joules. And from this is the main, we can consider it like transmitter is a node and receiver is a cluster head. So between them, there is a distance. So when node sends some information to cluster head, or cluster head sends information, aggregate information to the base station, some amount of energy spent. So after the first round, this spent energy is taken into consideration to select the cluster head for the second round and for other rounds. If you want to see the exact value, here that aggregation is in this value, and the energy spent between the antennas or receivers is in this value.
Okay, I would like to know which radio energy consumption model was used. Heinzelman? Did you use Heinzelman model for energy consumption? For example, in Ledge and SEP algorithms, they use the Heinzelman model when they do simulations.
Yes, each SEP and ZSEP parameters of configuration was taken as a benchmark to compare my proposed network. So of course, I also cite Heiselman paper in my paper also.
And also I read your thesis, and I would like to know what actually your difference of your proposed algorithm, because for example, in existing algorithms like SEP and Ledge, scientific writers, scientific people all modify cluster head, and you also modify cluster head, and you also used man model also approximately the same values get like in Ledge algorithm. I don't see exact difference. Can you clarify here?
Yes, I can show it from the, thank you, from the graph that Leach is taken as a blue one, red one is SEP, and the purple one is ZSEP, and the green proposed algorithm is the green one, EasySEP. These previous algorithms don't mention the remaining residual energy when selecting the cluster head. So it means any node in the network can be selected as a cluster head. Since after, like we can mention like this, for after the first round, some amount of energy spent on the nodes. So on the second round or other rounds, if the node with lowest energy can be selected as a cluster head, it may die before sending the data.
But here in the graph, we see almost the same values with the comparing algorithms. It is similar.
Proposed algorithm stabilizes the death of the first node.
Okay,
It
and
gives the stability.
okay, thank you. You said when you compare in your table that the stability of your proposed algorithm is better, but I don't see the real graph where you compare stability.
Yeah. Here we may see that maybe they are the same value, but the difference is around 1,300 rounds. 1,300.
Why you didn't show the table with exact values?
It's written in my paper.
Okay.
I show it in the paper.
Okay. Can I know what was the main motivation for modifying the cluster head? Because in your goal, first I see that you trying to improve network lifetime or data transmission or energy loss. Can you say certainly what was the goal?
Of course, the main goal is network is to improve the lifetime of the network. So all the researchers around the world try to improve this kind of routing algorithms to make the network survive more. Energy efficient routing algorithms comes from this point. So if once we improve the routing algorithm, it will spend less energy. And when we even, my proposed algorithm, when it selects even does the clusterization before sending the data. And in clusterization, they select the exact node to be as a cluster head. It will, in overall manner, improve the lifetime of the network. This is the main goal, to make the network serve more.
Okay, and one more question. What about the data transmission? For example, you proposed packet delivery ratio, yeah, like this is general metrics when we propose routing algorithms, but also the very important metric is data transmission. I mean, what about the throughput, for example, or jitter?
This research area in the scope of work, of course, throughput or bandwidth is not taken into consideration. We mentioned that simulation is done in laboratory environment and the data is sent almost full, no data loss. So that's why we show that in this condition, data are sent, all of them, and sent more than previous protocols.
How much megabit per second or gigabit per second, how much it was?
We don't count the speed throughput, just count the data delivered, how much data is sent in this value.
Also in your graph, I didn't see unit measurements. For example, what means here exact unit measurements?
Yes, here is the x-axis is the rounds. We perform, here is somehow 9,000.
Mhm.
And this is the nodes. number of nodes, and we see in which round node dies. Here is the same number of rounds and the packet delivered during this round. And residual energy, remaining energy on the nodes during this whole round. So we make, when we observe that 9,000 round is enough to see that more of the protocols almost finished. And the proposed algorithm still survives. You can see that maybe around 10 nodes are still alive here.
Also, I would like to see the measurements before clustering, what exact matrix was before and after clustering. You used here hierarchical clustering. Why did you choose hierarchical clustering? And what was matrix before clustering, after clustering? How we can compare that clusterization? Yeah, really improved the routing algorithm, because we can't compare it with previous version.
Actually, clusterization is taken so that no need for all the nodes deliver the data by itself. Because nodes may be very far from the base station and the distance is important. So if each node will send the data directly, it may lose its energy fast.
Do we have exact values?
Exact values. For clusterization, my proposed algorithm is already clusterized. So they already have cluster heads. They already have cluster in advanced nodes. But normal nodes, they don't have cluster. And they send the data directly since they're close to base station.
Okay, thank you. And can I know, did you do some real experiments? For example, we here see some simulations. And what about the hardware part? Maybe do you plan to use microcontrollers like ESP32, maybe Raspberry Pi or FPGA? It will be better to show in real equipment the real improvement, because simulation here can't really show the importance of that sensor network. And here you said about the mesh network, but I didn't see nothing about mesh network. It's only sensor network, because the nature of mesh network is really different. Their nodes should be dynamic, but here you have static nodes and it is like a wired network. Can you explain this?
Yeah, thank you. Mesh is actually about the interconnection of nodes. So it's a topology of the network. So the nodes can be mobile or can be fixed. I mentioned the fixed nodes. So since nodes are connected between each other, interconnected.
But there they should have gateway, for example, gateway and mesh routers and gateway mesh routers between the internet connection. But here you don't have some like these nodes. You only have cluster head, and you modified the cluster head like in Ledge and SEP algorithms, and they usually do for static wired networks. Those algorithms could work for wired networks, especially.
Maybe for wired networks also performs the same, but the research area is wireless network. And as from your previous question, Android type, Arduino type, or Raspberry type, or any device which is connected to the network can be considered as a node. Even FPGA, any device. So once they're connected between each other, in real life implementation, in these companies, we try to make a sensor bit on the door to count the employers entering the room. So maybe they have a process, maybe they have a turn on a mobile phone or any type of device which can be detected when when entering the network. So since they enter the network and network detects this intrusion, let's say intrusion, and find out that someone is in the network.
The last question, what was the parameters of your transmitter and the receiver? For example, about the power distance between nodes, free path loss propagation, for example.
I didn't show them in the presentation, but I can show it in the paper, the exact values, the distance. I show only the number of nodes, the whole network parameter, the energy of these nodes, the energy spent when receiving and transmitting the data. According to these parameters, we count which energy spent and which energy is remained in the node. And that's the parameters enough for us to estimate the whole network lifetime.
And did you calculate the power between transmitter and receiver using the free path loss propagation model?
We assume that they are connected. As I said, we mentioned it in the environment, in laboratory environment, and we don't mention that packet is lost, or connection is bad, or there is interference, which may affect the data.
What was the value of SNR, for example, between the transmitter receiver? Because in clear channel, we get another value. For noisy channel, we get another value, for example, for bandwidth. And maybe it was ideal channel. How we can know?
Since it's only a simulation, we just assume. We don't. I didn't.
Did you use Guasan noise?
Evaluate this signal strengths. Just mention that nodes are
The
connected.
power of signal, you mean? Yes.
Don't mention the power signal, SNR, as you said. Time division, multiple access, when the data is sent or the data is received. We just mentioned that the nodes are connected between each other and that this connection is enough to deliver the data and enough.
Okay,
to
I understand you more concentrated on the mathematical model here, yeah? Between the transmitter receiver, the distance,
Yes, we
how to locate, I mean, how to locate them.
how to locate
Nodes, for example. Nodes,
Nodes.
how to, yes, I mean, how to distribute that nodes in your network.
it is located randomly. When we simulate, we see that nodes are located randomly. We don't suppose that some nodes are close, all the nodes are close to the base station, or all the nodes are far from the base station. They are located randomly.
And in your thesis title, we don't see that like words like energy or sensors. It's like about the routing algorithm for wireless mesh networks. It's like for general networks. First, I thought that this for general networks, but it was sensor. It's better to clarify.
Okay, thank you.
We have some questions in online presence, maybe.
Yes, can I ask questions?
Please open the window. Okay.
So thank you very much for the presentation. I have several questions. First of all, can you please clarify what is the main contribution of EasySAP in terms of like algorithmic improvement? Like the main contribution.
Thank you very much. The main contribution is obtained threshold value, according to which the cluster head is selected, and it's selected according to its remaining value, residual energy. which will identify which cluster, which node to be chosen like a cluster head.
Okay. And the next question is like, why did you decide to divide the network into 3 zones, like zone 1, 2, and 3? Like, why?
Thank you. We assume that some nodes have less power and they should be located near to base station, not to lose their energy after few rounds or after a short time of a network running. So we assume we add some extra value and call them advanced nodes and separate them from zone 1 and locate it in zone 2 and zone 3. And only between them, among them, the clusterization is occurred and the cluster head is selected.
Okay. And also I have, so this is the table about simulation, right? And you mentioned you chose these values because of benchmark. So like 9,000 rounds, is it also like was chosen because of some benchmark? Like why 9,000?
Yes, we see that 9,000 is more than enough to see that more of previous or other algorithms comparing already finished, like dead. And we see that even 9,000 is not enough for proposed algorithm to show the how long does it serve. Maybe in 10,000, it will be almost finished. Like,
Okay.
like no live nodes in the network.
Can you please again explain in details how do you calculate the optimal number of clusters? Like it's k-opt.
We just assume that according to number of nodes, 4 or 5 will be chosen. It's not it's taken from this equation, and this is cited in the paper. So this is a number of optimal cluster heads to be chosen. Actually, it's in the paper cited from previous researchers from the benchmarking algorithm.
Okay. And the last question is, so how can your protocol handle node failures dynamically? Is it possible?
Sorry, can you repeat?
How can EasySep handle node failures dynamically?
Handle
Node failures. Handle node failures dynamically.
We assume that in general, mesh network means that once one node is dead, it doesn't affect the whole network. Or otherwise, vice versa, if new node is added, it is reorganized itself and it doesn't affect the full network. So we just mentioned that one is dead and the other node is the whole network continues surviving. This is the main idea of mesh topology.
Okay, thank you. No other questions.
Thank you very much. Maybe others?
И добрый вечер. Я хотела задать вопрос. Я Черембаева Катя Асламбаевна. Я буду задавать на русском по телекоммуникации. Профессор Матинского энергетического университета и связи. У меня такой вопрос, Zhanserik, к вам. Как именно было реализовано разделение поля на зоны в зависимости от энергии узлов? Это первый вопрос.
Как были разделены ноды в зависимости
Как именно было реализовано разделение поля на зоны в зависимости от энергии узлов? Я не вижу по вашим 16 слайде, вы показали, у вас есть 1000 абонентов, но я видела в вашей статье 900 абонентов. Вы берете 100 узлов. Как вы разделяете здесь в зависимости от зоны?
Разделение, спасибо за вопрос. Разделение было в зависимости от энергии, которая у них есть изначально.
Ваша кластеризация же, да? Правильно же? Вы же рассматривали кластеризацию, да? Для чего вы рассматривали кластеризацию?
Когда есть кластеризация, не надо, чтобы каждый элемент или нода отправляли данные напрямую к базе станции и теряли на этом энергию. И, соответственно, влияло на работоспособность всей сети. Если каждая
Вот как
нода...
вы разделяли в этом при передаче информации, когда имеется 100 узлов, которые подключены 1000 абонентов по вашим графикам, да? Вы показываете здесь не энергоэффективности, вы показываете здесь протокол, какие протоколы можно использовать для передачи, ну, чтобы энергоэффективным были. У вас получилось ваш протокол, который показываете в зеленом виде. А где ваша энергоэффективность, которую показываете, что именно у вас при разделении на кластеризацию у вас получается энергоэффективный. И потом я не увидела у вас в этом протоколе, в этом слайде, какой лучше из этих протоколов при кластеризации. Вы просто словами говорите, что ваш протокол, что энергоэффективный полагается. Скажите, как вы разделили на зоны? Это первый вопрос.
Смотрите, энергоэффективность сети, она вычисляется по нодам, которые остались живы. То есть имеет до сих пор энергию, чтобы существовать в сети. Соответственно, они выдают энергоэффективность этого алгоритма. То есть сам роутинг алгоритм маршрутизации употребляет меньше энергии при обработке данных и при передаче данных.
Если вы говорите, что оставляется, остальные, которые вы откидываете, куда они денется? Остается в сети или она на очередь становится?
Они остаются в сети, но как бы без энергии. То есть они просто выключены.
Почему вы в статье не рассматривали, что именно из 100, как называется, из 1000 абонентов такие ближайшие, которые лежат или подключены к базовой станции, вы должны были это рассматривать. Я поняла ваш ответ. Второй вопрос. У вас каким образом измерялись эффективность сети, например, через коэффициент доставки пакетов или среднее энергопотребление? Я не увидела по вашей статье энергоэффективность оценки.
Энергоэффективность сети оценивается по количеству живых нодов абонентов сети. Чем больше живых нодов в сети, ну и, соответственно, тем больше пакетов передаются. Основная задача сети – это обрабатывать и передавать данные. Чем больше, тем лучше. Поэтому сам алгоритм маршрутизации должен быть легким при вычислении этих данных или при отправлении данных. Они напрямую зависят от живых нодов сети, которые все еще функционируют. А те, кто
Ну,
уже...
это понятно. По вашим расчетам это понятно. Вы рассматривали одну направление. Например, у вас кластеризация для чего делится? У вас 4 основных кластеров. Вы 1000 абонентов делите на 4 кластера. Один ставите вы как основной, остальные как это ведомым. Получается, вы для чего кластеризация рассматривали? Вы дальше не рассматривали. Вы покажите мне картинку, которую вы на кластеризацию показали.
Кластеризация сама по себе...
Да, которая круглая, да. Перед этим, по-моему, 14 слайд или Покажите, пожалуйста, это данные. Нет, круглые, которые на кластер вы разделили, ближайшие, которые лежат в вашей базовой станции. Вот, видите, вы только обобщенные показали, а вы должны были разделить, сколько абонентов в одном кластере. Вы просто словами написали, а кластер будет работать. Самый основной у вас кластер, я хотела задать вопрос, почему вы до конца не рассмотрели эти кластеризацию. Откройте теперь 16, который ваши графики.
Ага.
Где у вас, я не поняла, вы показали зеленым, черным и так далее цветами, да, но это протокола. А почему вы не показали относительную погрешность и абсолютную погрешность? При этом мы поняли вы в конце, вот сколько-то абонентов активны, столько-то абонентов неактивны. При этом энергоэффективность увеличивается, у вас написано, по-моему, 48%.
Да-да-да.
Это, как это? Вы объясните, пожалуйста.
48% по отношению к протоколу ZSEP.
Ага. А ваши?
Вот мой алгоритм показывает, что почти вдвое больше живых нодов остается в сети.
А сколько процентов в процентах? Скажите, пожалуйста, вы же защищаете...
48%.
Сколько?
48% мы учитываем как энергоэффективность сети.
Это которые ближе лежат, ближе подключены к базовой станции. А скажите, пожалуйста,
Это все ноды, которые показали показатель в целом по сети.
в целом, а ваши SZEP?
Ну, я это имею в виду, что все ноды, независимо это обычные ноды, которые лежат ближе к базе станции, или же те ноды, которые лежат, могут вообще очень далеко находиться от базы станции, но которые имеют кластеризацию и передают данные сначала ближе основному кластер-хеду, чтобы не терять на этом энергии. У него и так мало осталось энергии, ему лучше передать кластер-хеду, у которого больше энергии, чем у него. Независимо и относительно пройти еще один раунд, грубо говоря.
Ну, это понятно, чтобы найти пока какой ближе, это понятно. Скажите, пожалуйста, вы только симуляцию сделали, что ли? Код написали, моделирование сделали? А где, как это? Это вы сделали теоретическую модель сделали, а где ваши практические? Вы исходные данные взяли только на 150 метров. Я данные посмотрела, 150 метров данные, да, ну, квадратуры вы берете, а если до 1000 метров, а вы рассматривали, вы должны были сравнить. Просто я имею в виду по вашим графикам, вы только сравниваете протокола. А где ваше расстояние? Только вы берете 150 метров в квадрате. А обычно 150 метров в квадрате это не дает нам затухания сигнала. Мощность сигнала не снижается. Мы когда отходим от базовой станции, он должен закидывать другой нод. А теперь скажите, пожалуйста, у меня такой вопрос. Вопросов много возникает. Как изменилось положение базовой станции в экспериментах? Как это влияло на сравнение SZ с другими протоколами? Положение я имею в виду на практике.
Вы правильно заметили, что возможно 100 на 100 квадратных метров нету затухания сигнала. Это есть подразумевание, что симуляция была сделана в сфере лабораторного здания. То есть в лаборатории все...
Это обычная лаборатория, Нурлан, вы соглашаетесь со мной? Обычная лабораторная Wi-Fi, который подключается к одному Wi-Fi несколько студентов, несколько абонентов, а вы даже не рассматривали на большие расстояния. Обычно мощность теряется, когда более 1000 метров. Вот скажите, пожалуйста, на мой вопрос, ответьте, пожалуйста, который я задала. А как вы эксперимент на станциях? Вы не брали никаких данных?
Данные брались из бенчмарка, я не знаю, как это звучит по-русски. Те параметры и конфигурации, которые были заданы в предыдущих протоколах, они были взяты, чтобы на тех же конфигурациях показать улучшение предлагаемого алгоритма. То есть на тех же параметрах, что они использовали, мой метод вычисления основного элемента кластер-хеда на остаточной энергии показывает лучший результат. Вот это мы
Но
называем...
это на маленькие расстояния. Вы лучше свой протокол показали на маленькое расстояние. Я видела несколько работ индусов, пакистанцев, похожие на вашу работу. Просто у вас изменилось в графиках. Поэтому я задаю такие вопросы по телекоммуникациям. Почему вы не рассматриваете на большие расстояния? Почему вы не взяли экспериментов, которые ведутся на сотовых связях? Это же обычная практически лабораторная работа для бакалавров, которым вы данные задавали.
Эти данные брались конфигурации от бенчмарк, то есть вот тех алгоритмов,
Но
которые...
я знаю, это база данных, которые в интернете есть.
С чем я сравниваю свой алгоритм? То есть те алгоритмы предыдущие показывают на тех же параметрах вот такой показатель. А мой алгоритм показывает на тех же параметрах улучшение.
С чем вы доказываете? Я не увидела в графиках ваша абсолютная и относительная погрешность. Вообще докторанты должны это знать.
Ну, по графику, вот, опять же, могу показать, что на тех же параметрах, что были на всех протоколах, при выборе кластер-хеда на остаточной энергии показывает результат лучше, чем у предыдущих, которые этого не подразумевают.
Примерно скажите, пожалуйста, Зhanserik, примерно скажите, сколько процентов у вас наилучший? Я не говорю, что двойня там, конкретно процентов.
48% энергоэффективности
Это же
и...
все протоколы же вы сказали же.
Нет, это мой протокол относительно ZSEP.
Угу. Где написано у вас?
Мой звучит EasySEP, Extended the Zonal Stable Election Protocol. Вот здесь. Оно здесь не в процентах, я здесь указал обобщенно в 2 раза, 48 раз, или же это означает 34%, 1,4, 1,3. Сейчас у меня здесь где-то должно быть. Здесь
В одном
тоже.
канале сколько абонентов у вас?
100. Абонентов 100.
В одном канале. Задержки нету.
Задержки нету, мы не учитываем, что есть задержка, что есть интерференция.
Вы же трансмируете же, вы же от одной точки в другую точку передаете же.
Да, мы не учитываем, что есть интерференция, что есть шум, который могут повлиять на потерю сигнала или же на потерю пакетных данных. Мы берем, что сигнал очень хороший, и для нас важно, что ноды, абоненты соединены между собой. Это самый важный элемент. А дальше мы измеряем, когда он передает эти данные, сколько он потерял энергии.
Ну, это понятно. Вы скажите, вы
вот
самый лучший сигнал берете. У меня вообще, я по вашей статье я поняла, у вас вы анализируете, сравниваете протокола. А в технической части у вас достаточно, я хочу сказать, не до конца сделано. Вы просто в процентах говорите, в расчетах я не увидела, сколько там и так далее, сколько каналов. Теперь скажите, пожалуйста, чтобы качество сигнала было, какие критерии рассматриваются? Первый вопрос это. Из этого появляется вопрос. Качество связи.
Вы учитываете момент, реальный момент, когда есть база станций, когда есть сотовые антенны, когда есть интерференция, когда есть шум, который на все это влияет из окружения. Мы учитываем лабораторное окружение, когда нету этих шумов, когда нету этих интерференций, пересечения частот. Даже когда ноды между собой соединены, одна нода между ними не повторяется сигнал, frequency. Частота не повторяется. Мы учитываем все моменты, которые идеальны для того, чтобы ноды были между собой соединены. Это самый главный фактор.
А у вас не влияет? Ладно, вы сказали это в лаборатории. А у вас не влияет другие, чтобы появились шумы? У вас стены есть, у вас этажи есть. 150 метров – это 2 этажа.
Ну,
Чтобы качество... Да,
симуляция.
критерий в первую очередь это задержка. Вы должны внимание обратить на задержку. Если задержка есть, она ухудшается качество связи. У вас стены есть, бетонные есть, понимаете? Это вы не рассматривали, получается. Просто вы сравнили в данной статье, я прочитала, есть такие статьи, которые похожи на ваши. Вы просто взяли в лаборатории 150 метров, а критерии вы должны были рассматривать. Чем дальше идет, тем эта стена из чего сделана, она дает затухание сигнала. При этом теряется и энергия эффективности.
Спасибо. Вы, да, учитываете реальную ситуацию, мы учитываем симуляционный момент на MATLAB. Поэтому то, что вы говорите, они здесь не учтены. Нам было важно, чтобы ноды были между собой соединены. Этого нам хотелось, чтобы вычитать остаточную энергию нода и на этом базе улучшить состояние всей сети. Нам этого параметра хватало.
Хорошо, может, следующие вопросы? Okay. Yeah, okay, thanks. There is some question in the chat. I think Mr. Alisher Skabulov, yeah, wanted to ask. Можете открыть чат? Шейр экран уберите. Остановите. Случайно не запись остановили? Okay. Hey, technical question from Alisher Skabulov. I have a technical problem too. Maybe you can ask it, Alisher?
Here's a question. Did you consider connectivity in your calculation? He has a microphone problem, I think.
То есть отвечать на этот вопрос.
Yeah, please open.
Yes. Did you consider connectivity in your calculations? We suppose that connectivity is ideal, as we mentioned in laboratory environment, and it's for us more than enough to calculate the energy value spent, and depending on this energy value spent, we consider which node to be selected as a cluster head. And these parameters show us that taking into consideration only these parameters is enough for us to prolong the lifetime of the network. I think I could answer the question.
Thank you. Maybe I have just some simple question. You mentioned you tried some questions were related to practical appliance of your research. Can you elaborate on that? Where do you apply your results of your research practically?
First of all, it was applied in Malaysia since during research work and research internship, I was in Malaysia. So we supposed Arduino type devices, IoT devices, and perform a network. And when this network is interconnected, we ask like employers to enter the network. We just select it in the border of the door. And once this network is deployed here, one element entering the node with bracelet or Bluetooth device or anything which can affect the network will detect or sensor or sense this data. And same was done in 5 companies in Kazakhstan, mostly in Astana city, since I was located in Astana at that time. I have, of course, as I showed.
Okay, you
yeah.
have documents, but what was the practical value? What they got from your research?
So algorithm showed that network served good.
Good, reliable.
Yeah,
Okay.
reliable. Yeah.
Okay, thank you. Done.
I have a question. Thank you. So, did you plan initially to publish in the series of publication or dissertation? Why I'm asking, so how did you structure your novelty, aim, and objective of your research on your 3 publications? For example, what is your novelty part? What is your objectives? This is first
Thank
question.
you for your question. Introduction and the main body is consumed.
I'm interrupting you. No, I didn't mention about introduction. General, your dissertation research novelty. So which publication has about this?
In research allocation paper and in
Yeah, you have 3 publications.
One
Yes.
is review paper, which is like an introduction and the
So
literature review.
you mean you started from?
No, I first have started from EasySep.
Mhm.
Then when I find the results, obtain the results which is good for me,
Mhm.
later I published the review paper according to all this work I have done.
Mhm. Which publication has your novelty part?
Both two papers.
Қараңыз, қазақ мемлекет тілінде қойын. Сіз бастапқыдан диссертация емес 3 мақала ретінде жоспарладыңыз ба? Мен түсінгенім бойынша.
Жоспарладым. Неге? Өйткені сол моментте заң шыға қалды да. Былайша айтқанда.
Бұл сізге мотивация болды, иә?
Қатты мотивация болды маған, иә.
Түсіндім. Енді сол кезде сіз білдіңіз, сізде зерттеу жұмысыңыздың жаңалығы, объектив, яғни өз тапсырмалары қойылатын алға. Соны қалай жоспарладыңыз? Сіз енді бірден обзорный статьяда, мақалада сіз айтпайсыз ғой, мен жаңалығым осылай болады деп. Сіз бірінші ол үшін эксперименттік жұмыс жасайсыз деген сияқты. Сіз қай публикацияда, қай жаңағы key findings бар ғой, жұмыстың мақсаты, өзектілігі, практикалық значимость, солар қалай located on your publications?
Енді қазақша жауап берсем, жалпы мен өзім телекоммуникация саласында болғандықтан алдындағы профессор ханымның сұрақтарын жақсы түсіндім. Маған IT технологияның ішінде беспроводная сеть, сымсыз желілер өте жақын еді. Сондықтан актуальность екені түсінікті, ол IoT. Ол жаңа әлемдегі жаңа зат. Алгоритм маршрутизации, она всегда нужна. Өйткені мы с этим сталкиваемся, с этим работаем. Сондықтан мен білдім, егер примерно выстроить такую сеть, беспроводную сеть на базе, ол кезде как раз Arduino'лар шыға бастады, жаңағы ESP, OCK дегендер, сол чиптар на базе этих чипов были выстроены, разработаны FPGA модули деп айтуға болады ана, паты. Соларды қосу арқылы бір сеть құрып, сол сетьте уже можно экспериментировать некий алгоритм маршрутизации. Сөйтіп, жаңағы EasySep сол кезде ойыма келді. Примерно эксперименттер арқылы мен көрдім, что результаты есть. Біріншісі шыққаннан кейін, екіншісі уже задача была сделать вторую публикацию. Это research allocation метод.
То есть сіз зерттеу барысында некий ревью жасадыңыз, сол кезде сіз түсіндіңіз, қай направлениеға баратыныңызды?
Бір жарым жылдай оқу барысында, статьялар оқи арқылы, немен бастауға болатынын түсінікті болды. Әрине, жергілікті супервайзерім шетелдік неде жүрген кезде, international интерншипте жүрген кезде себепкер болды. Осы бағыттарда, осындай публикацияларда бірге оқу арқылы, талдау арқылы, зерттеу арқылы көп мәлімет алдым да, бірден өзім жақын болғандықтан кірісіп кеттім жұмысқа. Содан барып, 2 публикацияға шыққаннан кейін, негізгі contribution бар болғаннан кейін, мне оставалось сделать обзорную статью. Сондықтан ол ең соңғы болып шықты, обзорная статья. Чтобы дополнить третий элемент.
Иә, менде жаңағы Қатипа Чижимбаева ханымның несен жалғасқан сұрақ бар да. Сіз жауап бердіңіз, ол сізге айтып жатыр, сигналдың түрлі параметрлерін қарастырмадыңыз пейперларда, публикацияларда. Сіз жауап бердіңіз, что сіз симуляционный версиясын қарадыңыз. Енді сіз симуляция жасап жатқан кезде екеуінде сонда айырмашылық қандай ожидает, то есть күтілді сізде, және жоспар болды ма real кейспен эксперимент жасап көруге деген сияқты?
Сұрақ бөліп
иә
жібердім.
толықтырып жауап берсеңіз, өйткені бітпей қалған сияқты да сол сұрақтың жауабы.
Кез келген симуляциядағы шыққан результаттарды лабораторияда, мен өзім телекоммуникацияда жұмыс істеген кезде бізде лаборатория болған. Ол жердегі параметрлер ешқашан сыртқа шыққан кезде сәйкес келмейді. Өйткені шум өте көп, интерференция өте көп. Әуелі кабельден өткен жаңағы частота влияет на беспроводную сеть. Біз өте оңай қатты кезікеміз, таяғын жетіп былайша айтқанда зерттеп таппай болғанбыз не үшін екенін. Сөйтсек телевизор көрсететін кабельдегі частота влияла на беспроводную сеть. Как раз они были на одной частоте. Егер оны біз бәрін ескере берсек, жаңағы scope of work кеңейе береді да. Енді ол бір бет емес, бір статья емес, бір 10 шақты статьяға баруы мүмкін. Сондықтан біз оны бөліп алдық. Мы рассматриваем случай, когда есть лабораторный environment.
Онда мен кешіріңіз, онда менде мынандай сұрақ, соған қарсы сұрақ келіп тұр. Сізде жаңа меншін жасадыңыз ғой, citationдар өте осындай не дейді, жоғары болып жатыр. Мен де байқадым оны, осы защитаға келерден бұрын менде мынандай сұрақ болды. Ол повторная қайталама қорғауы. Докторанттың енді жұмыс өзгерте алмайды, не бойынша, талап бойынша, бірақ қандай өзгеріс бар мақаласында. Табиғи түрде ол citation тексеру, ол адамдармен сілтеме жасалып жатыр ма дейсіз. Өзіңіз анализ жасадыңыз ба? Сондай real кейсқа сіздің математикалық немесе теориялық түрдегі жасаған симуляцияңызды қолданды ма? Оларда қандай өзгеріс болды? Сіз өзіңіз оқып қарадыңыз ба? Анализ жасадыңыз ба? Өйткені бірінші мақалаңызда 100-ден астам сілтеме тұр. Екінші мен үшіншіде 30 қателеспен, біреусінде 21-ден жоғары. Сізге қызық болды ма? Мысалға, мен өзім зерттеуші ретінде кім маған сілтеме жасап жатыр? Соған қарай, future works'ым қандай болады деген сияқты анализ жасаймын. Сіз қалай жасайсыз? Жасадыңыз ба сондай?
Әрине, 2 жыл бұрын қорғаудан кейін бері қарай жаңа citationдар, сілтемелер 2 есе көбейген.
Жоқ, сіз қараңыз, нақтылаған направленияда Қатипа Шижімбаева сұрақ қойды ғой сізге, нақты real case жағдай сізде citation болған ба сұрақ, сондай?
Енді егер сол сілтеме жасаған, сайт жасаған сайталарды ашып қарасақ, жаңа заман технологиялар бойынша искусственный интеллект, artificial intelligence
сол направление.
робототехникада қолданған. Оны құрылыс саласына қолданған да. Одан кейін deep learning, machine learning ұмытып тұрмын, мен как раз аналитикасын жасап қойып едім, айтып қалам деп. Одан кейін
сол пейперларда сіз қараған, ревью жасаған сигналдың параметрлерін қалай қарастырыпты?
Дәл өйтіп көрмедім, дәл зерттемедім, қарамадым нақты. 100-ден аса сілтеме бар, оның бәрін қарап шығу енді былай.
Жақсы, мен түсіндім. Сіз қайта қорғауға қандай апдейт жасадыңыз? Ауызша қорғау түрінде, сіз енді дайындалдыңыз ғой, 3 жыл өтті, бірінші защита мен осы қорғаудың арасында. Өзіңіз future works ретінде қандай conclusion жасадыңыз болашақ зерттеу бағытыңызда?
Енді жаңағы телекоммуникация саласының қазіргі маман ретінде, жалпы осы салада оқығаннан кейін, ол networktар, жаңағы this network, ағылшынша айтып кетейін.
Әрине.
These networks can be used in new technologies like 5G or 6G. Even we can consider that small devices can perform this amount of frequency, even that it has a low computational power. So if you know, in China last month it has been launched 10G of 1.5 gigabit throughput downlink, and I suppose in the shortest time this can be also performed on small device like FPGA maybe. FPGA is supposed like platform of many devices on it. It can be a big device or it can be a small device, and all these devices are included in IoT. Devices connected to network or internet. So as a future work, artificial intelligence, quantum computing, which will concretize or increase the calculation value. Yes, and computer vision, whatever is in the future can be applied for this type of devices, and these devices can route in this type of network algorithm. Because the routing algorithm is the most affecting feature which affects the whole lifetime of the network. If the routing algorithm is very bad and takes very low peak energy, of course, we suppose that this device cannot be recharged. So for us, it's very important that this device have enough energy to prolong the lifetime. And usually, this device network is located far from the city.
So let's conclude my question, your answer, I mean. So how much differ your simulation case from real case experimental set?
I again can.
For example, if I would like in my future works to use your theoretical simulated proposed system, so how much it might differ from real case? What I should consider?
I just can offer you that this algorithm performs or prolongs the lifetime of the network for 48%. I don't know how you can improve it. Maybe in the future of your work, you can find, maybe you can do like this from cluster head to cluster head delivery. My routing algorithm suppose from cluster head to base station. You can do multi-hopping from cluster head to cluster head, or find the cluster head closer to the base station. Mine considers any of them which is higher in energy. So you can find that this cluster head is good enough for energy. This is good enough, and choose from between them which is closer to the base station. In this manner, yeah, you can improve my algorithm, I think, theoretically.
Okay, thank you so much. I think it's clear now to the question of previous experts.
Okay, let's move forward, I believe. Okay, so we have the supervisors, the speech now. Let's give the floor to domestic supervisor, Tamara Zhukabayeva, if she's ready.
Good afternoon, can you hear me?
Yep.
Good afternoon, dear chairman, members of dissertation committee and colleagues. It is my pleasure to present my review of the PhD thesis of Nurlan Zhanserik, and the dissertation devoted to solving one of the important problems in the field of computer networks. It means designs of optimization of routing algorithms for wireless mesh and sensor networks. And the relevance Nurlan's research lies in the fact wireless mesh networks play a key role in modern communication system, especially for Internet of Things environments. He shows his proposed new models and new ZEP algorithms contribute to improving network performance, scalability, and energy efficiency. Zhanserik has formulated clear scientific objectives conducted through analytic reviews of exciting approaches, and so developed original routing algorithms that demonstrate measurable improvements compared to existing protocols. And also his main scientific results of dissertation have been published in reputable international journals in the Web of Science and Scopus, such as IEEE Access. And his main research work, wireless mesh networks, it is citation has 113 citation, and also his ZEP algorithms has citation 33 citation. It means this demonstrates not only scientific novelty of his work, but also its international recognition. And in total, Zhanserik has 3 high impact factor journal papers. It means IEEE Access and 2 IEEE Access and sensors. And also he's participated in a major international conference in Germany, in Berlin. It is about wireless sensor mesh network. Also, he has bronze awarded in Russia, in Tomsk, and Nurlan is responsible and the goal-oriented researcher. During his doctoral studies, he has shown high motivation and persistent in achieving his research goals. And the dissertation Nurlan Zhanserik is completed scientific work, I think, containing original results of theoretical and practical significance. I fully support the recommendation of our Nurlan Zhanserik, the degree of Doctor of Philosophy in Computer Science. Thank you for your attention.
Thank you very much. There should be some speech from external supervisor. Maybe we can, I don't know, maybe we can read this. External supervisor?
Yes,
Someone?
here, Osman, here.
Okay, floor is yours. Mohammed Osman, please. Your mic is off. Yeah, please turn on.
Assalamualaikum warahmatullahi wabarakatuh. Today is a Good Friday. I'm sure that, as mentioned by Professor Tamara just now, and explained about Dr. Nurlan, I guess, right? He doing a very good job and managed to publish 3 Q2 journal under Web of Science. I'm sure that the contribution is good enough for the degree of philosophy. With that, I'm congratulate him for the very good success in publication at the international level. Thank you very much. Assalamualaikum.
Okay, thanks. Then we move to the next stage. So we have some official reviewers. First, we would like to hear Sayat Akhtanov, please.
Hello, do you hear me well?
Yep, we hear you.
Thank you. So, dear Chairman, members of the committee and colleagues, it's a pleasure to present my review to the PhD dissertation of Nurlan Zhanserik, titled Development and Research Routing Algorithm for Wireless Mesh Networks. I think that this research is highly relevant to today IoT and the smart city technologies. So where is the energy efficient and reliable data transmission is a key challenge. The work was done under state research grant, I think, supported by Ministry of Education of Science of Kazakhstan. Also, Zhanserik proposed a new hybrid routing algorithm called EZ-SEP, which improves how nodes in the wireless mesh network communicate and manage energy. It's a simulation. Simulation results show strong improvements such as network stability, for example, increased at 48%. It's a very reliable result. So packet delivery to 16% and energy use is reduced for 34%. And the number of DIT nodes also is mentioned before. It's decreased 2 times. The results were tested and implemented in several Kazakh international companies, and the author said that it's intellectual property. He has 2 intellectual property certificates and 7 publications in the Scopus, 3 Q1 and Q2 journals, and it's very great. I think even received the Best Paper Award in the Tomsk conference. In my opinion, this dissertation is original, scientifically sound, and practically valuable. I strongly recommend awarding Ms. Nurlan Zhanserik the degree of Doctor of Philosophy. Thank you.
Thanks. Do you have any comments related to this work so that candidate should answer to?
First comment about that this is work hasn't any practical results, such as, for example, implementation in the FPGA or from real SOCs. Maybe it's a first. And the second, it's there are also different difficult explanation about the network, mesh network. Because we can't, as you mentioned before, there are several problems, such as, for example, how to calculate energy efficiency and so on. Thank you.
Okay, thanks. Zhanserik, Nurlan, your answers.
Thank you very much. Yes, I will consider all of your comments in the future. and improve research area.
Okay, thanks. The next speaker is our second official reviewer, Rasim Suliyev. Dr. Rasim Suliyev, please, floor is yours.
Hello, dear chairman, dear committee members. Let me express my warm greetings to all of you. So actually we have worked with Zhanserik. I asked him several questions during last time when he was preparing for his defense. First time, I already gave him my opinions, my reviews. So let me just shortly indicate that the lifetime of a wireless sensor network is actually a very important in network design. So the reduction of the energy consumption in a network is very challenging actually task and also useful task. So the results that this research work contribute to two main attributes of the design of the network routing algorithm. So which are the energy efficiency and the service lifetime of a wireless sensor network. So this proposed new model will help to solve the problems of the energy efficiency in wireless mesh networks. Sensor, especially when we live currently in a world where the number of devices connected to the internet are much more bigger than the number of people. So this is a very crucial task. So, actually, also I have seen the publications of this young man, Mr. Zhanserik. So several publications are published in a highly ranked journal. So from my side, I support this work and think he deserves a PhD degree. This is my opinion. Thank you.
Okay, thank you. Do you have any comments for Mr. Zhanserik to work on, to consider?
So the questions that I was wondering he answered. Currently, I heard some very good questions that were that were sounded here. So I support his future work, especially with the practical side of his work. So I think that he will continue this work and show the practical values of his scientific work. Thank you.
Thank you. Zhanserik Nurlan?
Thank you, Mr. Rasim. I already have some publications in the wireless sensor networks, and they are in cybersecurity. And of course, as you mentioned, I will continue to improve algorithms, routing algorithms in this field. Thank you.
Okay, thank you very much. So now we move to the other stage, the discussion. So now anyone would like to speak out? No? Okay, good for that. Hanım, if you open the mic.
Before I want to explain the question of energy industry, дело в том, что она говорит о задержках, первых возмещений задержки, почему больше вынуждены. Мы говорим о умолчании от цифровых приборов, которые сразу отсекают все задержки, все функции. То есть все вы имеете смарт-телефоны, каждый идеальный звук, идеальное изображение, это цифровой сигнал. Он имел все сети цифровые сейчас, современные. Поэтому этот вопрос считаю, что он есть. Он это имел по умолчанию. Значит, вопрос такой, the first question. What do you say about your protocol SEP from the security point of view? It's the first thing. And the second a question, have you used the rules of ELA for optimization resources of the mesh network?
Thank you very much. We are in discussion stage, so short answers, please.
Yeah, thank you. Cybersecurity is mentioned in my other works, and it will be mentioned. If we mention cybersecurity, it will not be about routing algorithm. It's only in network, wireless sensor network. And yes, I have mentioned your algorithm as you said before, and I have cited them in my papers.
Okay, thanks. Maybe other online speakers like, yeah, thanks. Erlang.
Yes, I have used and I have cited that research area, as I remember.
Okay. Okay, thank you.
Thank you very much.
Any others? Maybe Kasambek, professor, can you say some words? Nope. Okay. I would just elaborate on the discussion today. It's a hard discussion today. We can see that. So it's a second defense. So first time Zhanserik Nurlan already presented his notes and we got the comments that the discussion was a little bit weak. So we didn't have a lot of questions related to the topic and so on. And I can see that today we have a lot of questions related to his topic. He tried to clarify from all the sides. From my side, I'm not an expert on the specifics, but I can see that he have the research specifically designed for restricted conditions, and he made some progress there. And the evidence of his publication and citations, we can see that this work is relevant. So yeah, okay, I would support that. Any others?
Article was published in good journals. IEEE Access, it is first quartile journal, and I think it is good job. I think that it is only your beginning. I wish good results in your scientific career.
Thank you very much.
Thanks. If there is no questions or comments, discussion, so let's move to the next step, which is okay, we need to proceed to the secret voting, but before that, we need to elect the counting commission. So, any proposals? We have a proposal to select some extra people who joined us today. So, Turlu Kajayeva Dana could be our head of the commission. Also, I would recommend to add the Al Haditi Mohammed Al Fathil to the commission. And also the Ajakin Kasambek professor, if you would agree, the three people would count the votes and announce the results. The voting will be hidden, it's online. And now we need to make a break, right, for the voting. Yeah, thank you very much. Let's have a break for the voting.
Саламатсыздар ма, әріптестер?
Welcome.
Жаңа түсінбей қалдым. Естімей қалдым жаңа моментті.
Жақсы, рахмет. Сол қазір сізде рұқсатыңыз болса.
Мен
Форма
сайлау комиссиясында деп жүрдіңіздер ғой, мен түсінемін. Шала-шала естіліп қалды. Интернет кішкене дұрыс болмай қалды да.
So the link is sent to the chat. Thank you. Ссылка отправлена в чат.
Reviewers. Yeah, okay. Dear colleagues, we have 7 dissertation council members and 2 reviewers, so we need to get 9 votes. Yeah, please.
Голосование с теми двумя. Саяттар голосование etdi. Sizlar meni atmışıp durma. Ашықпаймын.
Мен дауыс беріп тастадым.
Okay. Professor Vitaly Levashenko, are you there?
Yes, I'm here.
Oh, thanks. We're going to send a link to your email. Please, can you vote now? So we need your vote. Okay.
Okay. My email in common chat.
Common chat, yeah. Okay, we're going to just directly send to you because we distributed by WhatsApp, but unfortunately we don't have your WhatsApp number, so we're going to send to email.
Unfortunately, I have not WhatsApp.
Okay,
Sorry.
okay, no worries. No worries. Okay. Have you received it?
Sorry, no.
Okay, we just sent it.
No yet. One moment.
Did you get it?
Oh, sorry, I checked my email, but I have not any message from you. Maybe you can send this URL to chat.
I will send you directly.
Okay. Now I see it. Okay. Cancel. Okay.
Okay, chapter. We
Yes,
have
yes,
it.
one.
So there's no other person in the room, so then
Yes,
it's okay.
it was with the doctor that was positioned. Okay.
Thank you very much.
Okay, I sent my response.
Thank you, Professor. Okay.
Okay.
Жаңағы результаттар қай жақта шығып жатыр? Мына жаққа ма? Шете ма? Его еще заполнить? Количество? Давайте. Қанша адам? 9 адам ғой, иә? 9 адам дауыс берді, деп па? Жорағайым деп жазайын ба?
Болды, керек емес. Мына жерге жазасыз. Кеңес мәжілісі менде 10 болу керек.
10 деп жазайын ба?
Бірақ қатысқаны 9 дейсіз.
10, 9.
Екі ресмиден қатысты.
2.
Олар тең дауысқа ие. Бюллетендердің саны, жабылтылған бюллетендердің саны жалпы 9. Мына жерде 9. Енді 0. Тағы да 0.
Ешкімге айтпаған ба, әйтеуір слава богу. Арасында ұрыс болып қалып жүрмесін, деп па? Қай жерден түгелінен бастап оқи берейін ба, бас жағынан? Дауыс беру нәтижесінде
Okay, we are ready for the next stage. So we resume the work of the dissertation concept to announce the results of the secret voting. The floor is given to the chairperson of the Counting Commission, Dana Turlukhojaeva, please.
Thank you. Дауыс беру нәтижесі. Философия докторы, PhD, немесе BN бойынша ғылыми дәрежесін беру үшін дауыс берген 9 адам. Диссертацияны қайта қорғауға жіберген 0 адам. Философия докторы, PhD, немесе BN бойынша докторы ғылыми дәрежесін беруден бас тартқан адам 0. Құттықтаймыз PhD атануыңызбен.
Voting results, there are 9 votes for the assigning the PhD degree for the applicant candidate, 0 votes for the sending the PhD for the redefense, and 0 votes against. Congratulations, the degree of PhD is assigned.
Okay, sorry. We need to approve the results. So who is in favor of the approving the protocol for County Commission? From the chairs? Okay, yep. Who against? No, any abstentions? That the protocol of the Counting Commission is approved. Thank you. And the dissertation concept for the education program 6D070400 Computer Systems and Software at the University, based on the public defense of the dissertation of Zhanserik Nurlan on the topic development and research of a routing algorithm for a wireless mesh network, has decided a petition for the committee for the awarding of the degree of Doctor of Philosophy, PhD, for the ministry. So thank you. The candidate is given the floor for the final remarks.
Thank you very much, again for participating in this Viva for the second time. That's all. Thank you.
Thank you. Okay, so the dissertation course is concluded. Thank you all. Wish you best. Thanks.
Okay, thank you. Goodbye.
Congratulations from Malaysia. Thank you.